Hello class, in this video I'll be showing you how to find the relative extrema of a function by applying the first derivative test. Let's begin. For example 5, we want to find all relative extrema for the function g of x. But before we can do that, we need to determine the domain. The domain of g of x is all real numbers. And that is because if we rewrite g of x as x squared divided by e raised to the 3x power, e to the 3x will never equal 0. Which means that there are no values of x that will make g of x undefined, so the domain is all real numbers. Now to find the critical numbers. To determine the critical numbers, we need to figure out where the derivative is equal to 0 and where the derivative is undefined. Applying the product rule, the derivative of g will equal 2x times e raised to the negative 3x power plus x squared times negative 3 e raised to the negative 3x power. I'm going to set the derivative equal to 0 and multiply the negative 3 times the x squared. That will look like this. To solve for x, I'm going to factor out a common factor of x times e raised to the negative 3x power. That will look like this. Now I'm going to set the three factors equal to 0. So we have x is equal to 0, e to the negative 3x is equal to 0, and 2 minus 3x is equal to 0. For the equation on the left, x is already equal to 0, so there's nothing to do. For the equation in the middle, there is no solution. And for the equation on the right, x is equal to 2/3. Since 0 and 2/3 are in the domain of g, we can conclude that they are critical numbers. Now to determine where the derivative is undefined. The derivative can be rewritten like this. The denominator for both terms is e raised to the 3x power. If e raised to the 3x power is equal to 0, then the derivative will be undefined. However, there is no solution to this equation. This means that the derivative will be defined for all values of x, and the only two critical numbers are x is equal to 0 and x is equal to 2/3. Now to create the number line. On this number line, I'm going to include both critical numbers because this is where the derivative is equal to 0. Now there are three intervals to test. The first interval is where x is less than 0. The second interval is where x is between 0 and 2/3. And the third interval is where x is greater than 2/3. I'm going to start by testing the interval where x is less than 0. If I let x equal negative 1, then the derivative at negative 1 is approximately negative 100, which is less than 0. This means that the derivative is negative when x is less than 0. Now to test the interval between 0 and 2/3. I'm going to let x equal a half. The derivative at 1/2 is approximately 0.06, which is greater than 0. So the derivative is positive when x is between 0 and 2/3. And finally, I'm going to test the interval where x is greater than 2/3. And finally, I'm going to test the interval where x is greater than 2/3. So if I let x equal 1, the derivative at x is equal to 1 is approximately negative 0.05, which is less than 0. This means that the derivative is negative when x is greater than 2/3. Now I'm ready to apply the first derivative test. And I will start with the relative minimum. Since x is equal to 0 is a critical number, and the derivative changes from negative to positive at x is equal to 0, there is a relative minimum at x is equal to 0. The value is 0. For the relative maximum, we have Since x is equal to 2/3 is a critical number, and the derivative changes from positive to negative at x is equal to 2/3, there is a relative maximum at x is equal to 2/3. The value is approximately 0.0601. I will leave it up to you to graph this function into Decimus to verify these results. And we are done.